Hello dear children, how are you all? I hope all are fine. So in our last class we had a discussion on angle between the two lines. Condition for lines to be perpendicular and another one the condition for lines to be parallel. ಇದರ ಬಗ್ಗೆ ಡಿಸ್ಕಷನ್ ಮಾಡಿದ್ದೀವಿ. So in this class I am going to discuss about very important topic, shortest distance between two lines. Okay, then how to find the shortest distance? ನೀವು 2-dimensional geometry ಕಲ್ತಿದ್ದೀರಾ in case of straight lines. When you consider two lines in case of 2-dimensional geometry, either they are parallel or intersecting alva. So either they are parallel, ಇಲ್ಲಿ ನೋಡಿ, here we have this line. So these two lines are what? Parallel. We get another set of line, that is when you consider two lines, so they are intersecting, right? So these two are parallel, these two are intersecting line. This is a parallel lines. These two are intersecting. Intersecting lines. So when two lines are parallel, then how to find the distance? It is very simple. The perpendicular distance between these two lines. Okay. So this represent the shortest distance or distance between the two parallel lines. Illanagappa namage perpendicular distance. So when you consider for intersecting lines, so when we have the intersecting line, the shortest distance, you know, here with the point of intersection, the shortest distance or distance between these two lines is 0. ಏನಾಗುತ್ತೆ ನಮಗೆ ಡಿಸ್ಟೆನ್ಸ್ ಬಿಟ್ವೀನ್ ದೀಸ್ ಟು ಲೈನ್ ಈಸ್ 0. ಅರ್ಥ ಆಯ್ತು ಮಕ್ಕಳ? ಸೊ ದಿಸ್ ಇಸ್ ದ ಕೇಸ್ ಆಫ್ 2-dimensional geometry. So when you consider 3-dimensional geometry, so these two lines as it is, you get the same lines. When two lines are parallel in case of 3-dimensional geometry, so obviously their distance is the perpendicular distance between them. ಅರ್ಥ ಆಯ್ತಲ್ವಾ? Their distance is perpendicular distance between them. So whereas in the case of intersecting lines, in case of 3-dimensional geometry, here also the shortest distance between intersecting line is also 0 in case of 3-dimensional geometry. So we get another set of lines when you consider for two lines. So those lines what we call as a skew lines. ಏನಂತ ನಾವು ಅದಕ್ಕೆ skew lines. So skew lines are non-parallel, they are non-intersecting and non-coplanar. So those lines what we call as a skew lines. ಅರ್ಥ ಆಯ್ತು ಮಕ್ಕಳ? Those lines what we call as a skew lines. Just remember here. So this is the 3-dimensional space, this is the cube. Suppose ಇಲ್ಲಿ ಒಂದು plane ಇದೆ, here we have another plane. So this line is passing through this plane and we have second line. So this is passing through another plane. So obviously these lines ಏನು ಬರ್ತಿದೆ ನೋಡಿ, red and green ಕಾಣ್ತಿದ್ದಿಲ್ಲ. So these two are non-intersecting and they are not parallel, right? And they are lies in different plane. They are not coplanar. So those lines what we call as a skew lines. ಅರ್ಥ ಆಗ್ತಿದೆ ನೋಡಿ, ಇದು ಈ ಪ್ಲೇನ್ ಅಲ್ಲಿ ಇದೆ. So this line is passing through another plane. This lies in another plane. ಅರ್ಥ ಆಯ್ತಲ್ವಾ? So these two lines what we call as a skew lines. ಅರ್ಥ ಆಯ್ತಲ್ವಾ? So how to find the shortest distance between them? ಅದಕ್ಕೆ ಮೊದಲು we go with the definition of skew lines. Definition ಏನಿದೆ? Skew lines, non-intersecting and non-parallel lines are called skew lines. ಅರ್ಥ ಆಯ್ತಲ್ವಾ? Non-intersecting and non-parallel lines are called skew lines. Just write down definition. Definition is very important. So next we are moving for very important one, shortest distance between two skew lines. ನಿಮಗೆ ಟೋಟಲ್ 2 derivations ಇದೆ. ಒಂದು shortest distance between or distance between two parallel lines, another one distance between two skew lines. First we will discuss about the skew lines. Then how to find the shortest distance between two skew lines? So just remember, so green and yellow ಕಾಣ್ತಿದ್ದೇವಲ್ಲ, red ಇದೆ. So these two represent skew lines. Suppose this is, I will take this as here L1. Let's have a brief discussion about the shortest distance between two skew lines. ಅದರ ಬಗ್ಗೆ ಹೇಳ್ತೀನಿ ಕೇಳಿ. Here we have the line, this is another line, these two are skew lines. They lies in different plane, they are non-planar, non-parallel and they are non-intersecting. Suppose this line is passing through the point, ಇಲ್ಲಿ point ಇದೆ, this is the point, I will take this as a S, this line is passing through another point T ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀನಿ. Okay, then remember the shortest distance between these two line is the projection of ಇಲ್ಲಿ line ಬರುತ್ತಲ್ಲ, the projection of this vector on PQ. So what is PQ? So PQ ಏನು ಬರುತ್ತಲ್ಲ, this is the perpendicular distance between them. ಇದಕ್ಕೆ ಏನಂತೀನಪ್ಪ, perpendicular distance. So this represent the distance. How to find this distance? This is nothing but the projection of ST. I will take this as S and this as T. Detail ಆಗಿ ಹೇಳ್ತೀನಿ ನಿಮಗೆ. So ST, this is PQ. Therefore the shortest distance between these two skew lines is the projection of ST and PQ. ಅರ್ಥ ಆಯ್ತಲ್ವಾ, ಪ್ರೊಜೆಕ್ಷನ್ ಆಫ್ ST and PQ. Okay, just remember ಇಲ್ಲಿ ಡಯಾಗ್ರಾಮ್ ಯಾವ ಥರ. ಸೊ ದಿಸ್ ಇಸ್ ದ ಕೇಸ್ ಆಫ್ 3 dimension. ಸೊ when you consider same lines in 2 dimension geometry ಬರಿಬೇಕಾರೆ, ನೋಟ್ಬುಕ್ಕಲ್ಲಿ ಬರಿಬೇಕಾರೆ ಏನು ಯಾವ ಥರ ಕಾಣುತ್ತೆ, ಜಸ್ಟ್ ಲಿಸನ್ ಹಿಯರ್. ಇಲ್ಲಿದೆ ನೋಡಿ, ದಿಸ್ ಈಸ್ L1, ಐ ವಿಲ್ ಟೇಕ್ ದಿಸ್ ಇಸ್ ಹಿಯರ್ L2 ತೊಗೊಳೋಣ. ಸೊ ಅನ್ನೋದ್ರ ಲೈನ್ ಇಲ್ಲೊಂದಿದೆ, ದಿಸ್ ಈಸ್ L2, L1, ದಿಸ್ ಇಸ್ ದ ಲೈನ್ L1, ದಿಸ್ ಇಸ್ ಲೈನ್ L2. ಸೊ ಇದು 2 dimension geometry ಕಾಣಬೇಕಾರೆ, ಪ್ಲೇನಲ್ಲಿ ಬರಿಬೇಕಾರೆ. ಸೊ ಆಬ್ವಿಯಸ್ಲಿ ದೀಸ್ ಟು ಆರ್ ಸ್ಕ್ಯೂ ಲೈನ್ಸ್. Suppose this L1 is passing through point S, or S be a point on the line, corresponding position vector is A1, vector A1. So take another point on line L2, that point is T, corresponding position vector is A2. Okay, then join these two, join ಮಾಡ್ತೀನಿ. So this represent vector ST ಆಗುತ್ತೆ. ಏನು represent ಮಾಡುತ್ತಪ್ಪ, vector ST. Okay, so we have another thing. So here we have this is the perpendicular vector, or the magnitude of shortest distance vector between line L1 and L2. I will take this as P and this as Q. ಏನಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಪ್ಪ, Q ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. ಸೊ ಇಲ್ಲಿ ಈ ಥರ ಕಾಣುತ್ತೆ, ಬಟ್ 3 dimension geometry ನೀಟಾಗಿ ಅರ್ಥ ಆಗುತ್ತೆ. ಜಸ್ಟ್ ರಿಮೆಂಬರ್ ಹಿಯರ್. ದೆನ್ ಹೌ ಟು ಫೈಂಡ್ ದ ಶಾರ್ಟೆಸ್ಟ್ ಡಿಸ್ಟೆನ್ಸ್ ಬಿಟ್ವೀನ್ ದೀಸ್ ಟು ಲೈನ್. So this is perpendicular here, this is also perpendicular. Then how to find the distance? This is nothing but the projection of vector ST on PQ. ಏನಾಗುತ್ತೆ, ಪ್ರೊಜೆಕ್ಷನ್ ಆಫ್ ST on PQ. ಇಲ್ಲಿ ಕರೆಕ್ಟಾಗಿ ಅರ್ಥ ಆಗುತ್ತೆ ಕೇಳಿ ಈ ಡಯಾಗ್ರಾಮಲ್ಲಿ. ಜಸ್ಟ್ ಅಬ್ಸರ್ವ್ ಹಿಯರ್. ದಿಸ್ ಇಸ್ ದ ಲೈನ್ L1, this is the line L2, these two lines are skew lines. Just observe here. And so here we have the point S, so here we have the point T. So this represent here ST. ಅರ್ಥ ಆಯ್ತಲ್ಲ. ಸೊ ವಾಟ್ ವಿ ಹ್ಯಾವ್ ಹಿಯರ್, ಎಲ್ಲೋ ಪೆನ್ಸಿಲ್ ಕಾಣುತ್ತೆ ನೋಡಿ, ದಿಸ್ ಇಸ್ ದ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಡಿಸ್ಟೆನ್ಸ್ ಬಿಟ್ವೀನ್ ದೆಮ್. ದಿಸ್ ಒನ್ ಏನು ತೊಗೊಂಡಿದ್ದು ನಾವು PQ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ದೀವಿ, ದಟ್ ಬಿಕಮ್ಸ್ PQ. ದೆನ್ ವಾಟ್ ಇಸ್ ದ ಶಾರ್ಟೆಸ್ಟ್ ಡಿಸ್ಟೆನ್ಸ್ ಬಿಟ್ವೀನ್ ದೆಮ್, ಪ್ರೊಜೆಕ್ಷನ್ ಆಫ್ ST ಆನ್ PQ. ಅರ್ಥ ಆಯ್ತು ನೋಡಿ, ಪ್ರೊಜೆಕ್ಷನ್ ಆಫ್ ST ಆನ್ PQ. ಅರ್ಥ ಆಯ್ತಲ್ವಾ. ದಿಸ್ ರೆಪ್ರೆಸೆಂಟ್ ದ ಶಾರ್ಟೆಸ್ಟ್ ಡಿಸ್ಟೆನ್ಸ್ ಬಿಟ್ವೀನ್ ದೆಮ್. ಸೊ ಇದು ಡಿರೈವೇಷನ್ ಡೀಟೇಲಾಗಿ ಹೇಳ್ತೀನಿ. ಸೊ ಇದಕ್ಕೆ ಮೊದಲು ಇಲ್ಲಿ ಇಂಪಾರ್ಟೆಂಟ್ ಥಿಂಗ್ ಯಾವುದು, ಪ್ರೊಜೆಕ್ಷನ್ ಆಫ್ ST ಆನ್ PQ. ಇಲ್ಲೇನು ಕಾಣುತ್ತೆ ನೋಡಿ, ವಿ ಹ್ಯಾವ್ ದ ಥಿಂಗ್ಸ್ ಹಿಯರ್ ನೋಡಿ, ಇಲ್ಲಿ ಒಂದು ಲೈನ್ ಇದೆ, ಸೊ ಇಲ್ಲೊಂದು ಲೈನ್ ಇದೆ, ದಿಸ್ ಈಸ್ ಓಕೆ. ಸೊ ಇದು ದಿಸ್ ರೆಪ್ರೆಸೆಂಟ್ ಹಿಯರ್ ST. ಸೊ PQ ಇಲ್ಲೆಲ್ಲ ಬೇರೆ ಕಡೆ ಕಾಣ್ಬೋದು, ಬಟ್ ಆ್ಯಕ್ಚುಲಿ ಇಟ್ ಈಸ್ ಲೈಸ್ ಹಿಯರ್. ಸೊ ದಿಸ್ ಈಸ್ P, ದಿಸ್ ಈಸ್ Q. ಡಿಸ್ಟೆನ್ಸ್ ಏನಾಗುತ್ತಪ್ಪ ನಮಗೆ, ಡಿಸ್ಟೆನ್ಸ್ ಆಫ್ ದಿಸ್ ಒನ್ ST, this one is PQ. ಗೊತ್ತಾಯ್ತಲ್ವಾ, this is ST and this is PQ. If I take this as here theta, the angle between vector ST and vector PQ is theta. Okay, so what about cos theta ಏನಾಗುತ್ತೆ, cos theta ಹೇಳಿ, cos theta is equal to, tell me here, cos theta ಏನಾಗುತ್ತಪ್ಪ, ratio here PQ divided by ST, right, adjacent divided by hypotenuse, PQ divided by ST. Now take cross multiplication, PQ is equal to ST into cos theta ಆಗುತ್ತೆ, ST into cos theta. This is the important thing. ಸೊ ಇದೊಂದು ಬಂತು ಅಂದರೆ ವಿಲ್ ಫೈಂಡ್ ದ ಶಾರ್ಟೆಸ್ಟ್ ಡಿಸ್ಟೆನ್ಸ್ ಬಿಟ್ವೀನ್ ದೆಮ್. ದೆನ್ ಆ್ಯಂಗಲ್ ಬಿಟ್ವೀನ್ ಕಾಸ್ ಥೀಟಾ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತೀವಿ, ಥೀಟಾ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತೀವಿ. ಇಟ್ಸ್ ವೆರಿ ಸಿಂಪಲ್. ಸೊ ಥೀಟಾ ಏನಾಗುತ್ತಪ್ಪ ನಮಗೆ, ವೆಕ್ಟರ್ PQ into ST divided by mod of PQ into mod of ST ಆಗುತ್ತೆ. ಸೊ ದೇರ್ ಫಾರ್ PQ is equal to be taken here modulus ST into mod of PQ. This is very important. ಅರ್ಥ ಆಯ್ತಾ ಮಕ್ಕಳ. ಸೊ ಇನ್ನೊಂದು ಇದಾದ್ಮೇಲೆ ಏನು ಫೈಂಡ್ ಔಟ್ ಮಾಡೋದು, ವಿ ನೀಡ್ ಟು ಫೈಂಡ್ ಕಾಸ್ ಥೀಟಾ. ಸೊ ವಾಟ್ ಈಸ್ ಥೀಟಾ ಹಿಯರ್, angle between PQ and ST. Okay, so cos theta ಏನಾಗುತ್ತೆ, cos theta is equal to vector PQ with vector ST ಇದೆ, this angle is theta, so therefore this becomes vector PQ dot vector ST whole divided by mod of PQ into mod of ST. This is the, so these two are the important thing we should remember while deriving the shortest distance between two skew lines. This is important here, PQ and cos theta. Next step is very simplification and substitution. Our name clean definition derivations barutte. Shortest distance between two skew lines, you will get the formula. So we will get the formula in both vector form as well as the Cartesian. Nowadays students, I would like to discuss the derivation of the shortest distance between two skew lines. So this derivation is very important for 5 marks question. So in exam alli 5 marks question barutalla alli keltare, is important for 5 marks question. Okay, so lines alli 3 derivations ide, planes alli 3 derivations. So these derivations are very important for PU board exam point of view. They last for 5 marks question. Okay, just observe here. So you are discussed, right? So skew lines. So what are skew lines? Non-intersecting and non-planar or non-parallel lines are called skew lines. Here we have the two skew lines. This is the line L1 and we have another line L2. So I will take this as L1 and this as L2. So these two are the two lines. So in so here line L1 we take the point S, let S be the point lies on the line L1, corresponding position vector is A1, vector A1, and another point T thrown, this is the point T on the line L2 with the position vector A2, with the position vector A2. Okay, then take the perpendicular distance. So this point what we take as a P and Q, so this is perpendicular to both L1 and L2. Right. So if you join these two, we get the vector ST barute. This is here vector ST. Then we are discussed the shortest distance between these two skew lines is the projection of vector ST on vector PQ. I repeat, the projection of vector ST on vector PQ. So what is PQ here? So PQ is the magnitude of the shortest distance vector. So I will take this distance as D. And distance as D. So let's do the explanation. Let L1 and L2 be the two skew lines with equations. So equations enta hogodu. First equation is here, vector R is equal to vector A1 plus lambda into vector B1, and another equation vector R is equal to vector A2 plus mu into vector B2. So what is vector B1 and B2? So vector B1 is the vector parallel to the line L1 and B2 is the vector parallel to line L2. Okay, then let S be a point on the line L1 with position vector alva, with position vector A1, with position vector A1, and T be a point on line L2 with the position vector A2, with the position vector A2. Artha aitalva? This is the vector A1 is the position vector of the point S and A2 is the position vector of the point T. Okay. If PQ, so vector PQ, so vector PQ is the shortest distance or the magnitude of shortest distance vector if PQ is the magnitude of shortest distance vector, then the magnitude of shortest distance vector is the projection of vector st. Just remember the projection of vector st on vector pq. The projection of vector st on vector pq. So this is the case here. Okay. So the magnitude of shortest distance vector pq is the projection of vector st on pq. The projection of vector st on pq. Okay. Just observe here. This is very important. Nodi. So this is just like a cuboid. So here we have line. So this is passing through another plane. So this is the line, another line. This is also passing through different plane. So obviously these two lines are skew lines. So this is the point S on the line L1. This is the point T on the line L2. So this represents the vector ST. Vector ST. Then what is the distance between these two skew lines? The distance between these two skew lines is the perpendicular distance. Cillian represent this represent perpendicular distance. So how to find distance here? Projection of ST on vector PQ represent the magnitude of the shortest distance vector. Projection of vector ST on vector PQ. This is the point P, this is the point Q. So this is perpendicular to both L1 and L2. Just observe here. So just observe. So obviously line L1 is the line L2 is the line L1 and line L2. This is the line L1 and this is the line L2. This is the vector ST. This is the vector PQ. Then how to find the short distance is here? The shortest distance between these two lines is the projection of vector ST. This is the vector ST on vector PQ. Vector ST on vector PQ. Just observe here. So here we have vector B1 and B2 with them. Just here. So vector B1 and vector B2 is there. So vector B1 is line parallel to line L1. This is vector B1 parallel to line L1, and we have another line. This is here. I will take, this is the B2 tonana. I will take another one here, B1. So here this is the line L1. B1 is parallel to L1 and B2 is parallel to line L2. But the PQ, what we have the PQ is perpendicular to both L1 and L2. So obviously this vector, what we have the PQ is perpendicular to both B1 and vector B2. Vector B1 and vector B2. Then how to find the unit vector in the direction of PQ is B1 cross B2 divided by just magnitude of B1 cross B2. Okay, next we have that one. Here vector PQ is perpendicular to both vector B1 and vector B2. Here, so PQ is perpendicular to both vector B1 and B2. Hence, unit vector. So I will take this as here n cap. Unit vector n cap in the direction of vector PQ is given by n cap is equal to vector B1 cross vector B2 divided by modulus of B1 cross modulus of B2. This is a unit vector in the direction of P and Q. And okay, now tell me, so what is a vector having both magnitude as well as the direction? So ಇಲ್ಲಿ ಅಂತ ನಾನು vector PQ is equal to, just observe here. So what is D represent? The magnitude, right? D. Then what is the direction? Very good, that is n cap. PQ become vector PQ is equal to D into n cap. Just substitute n cap here. Therefore vector PQ ಏನಾಗುತ್ತೆ? D times of what is the n cap? B1 cross B2 divided by modulus of B1 cross B2. Modulus of B1 cross B2. So call this is equation number 1. Equation number 1. So what is D here? D ಬರಿಬೇಕಲ್ವಾ, where D is the magnitude of shortest distance vector. This D here, the magnitude of shortest distance vector. Okay, ಅರ್ಥ ಆಯ್ತಪ್ಪ? So vector PQ is equal to D into B1 cross B2 divided by modulus of B1 cross B2. Okay, next let theta be the angle between vector ST and vector PQ. Vector ST and vector PQ is the, what is the here? Vector ST and vector PQ. Let theta be the angle between vector ST and vector PQ. Then so PQ, just observe here. So PQ can be written as ST into cos theta ಬರುತ್ತೀವಿ. PQ is equal to ST into cos theta. How comes PQ is equal to ST into cos theta? Just observe here. Here we have the line L1 and here we have the line L2. So this is the vector ST and this is here PQ. So here just now observe ಮಾಡಿ. So this is the angle. So this is the angle theta between the vector ST and vector PQ. Between vector ST and vector PQ. ನೋಡಿ vector ST ಇದೆ. So ಇದು ಯಾವ ತರ ಕಾಣ್ತಿದೆ ನೋಡಿ, just observe here. This is S, this is T and PQ ಇದೆ. So this is a vector ST ಇದೆ. Corresponding magnitude ನಾನು ST ಅಂತ ತಗೊಂತೀನಿ. Just ST represent the magnitude. So vector ಮೇಲೆ arrow mark ಬಂದ that represent vector. This is ST and this is PQ. This is what we have theta. Now define for cos theta. Cos theta ಏನಾಗುತ್ತಪ್ಪ? Adjacent by hypotenuse. What is adjacent here? Adjacent is PQ. Right. So what is the hypotenuse here? ST. ಅರ್ಥ ಆಯ್ತಲ್ವಾ? This is how cos theta obtained here. Cos theta is equal to PQ divided by ST ಆಯಿತು. What is PQ? Then PQ is equal to ST into cos theta. So why we take modulus here? Because obviously PQ is always non-negative alva. That's why we taken here modulus. The distance PQ. ಅರ್ಥ ಆಯ್ತಲ್ವಾ? This is how the cos theta obtained. Take a pause and note down all the things what I have written here. Call this as equation number 2. So PQ is equal to ST into modulus of cos of theta. So this is equation number 2. Then just observe here. So when we have the two vectors, vector A and vector B, then how to find the angle between these two vectors? We have two formula in case of cos theta and in case of sin theta. Here we are using the formula for cos theta. Cos theta is equal to A dot P divided by mod A into mod B ಆಗುತ್ತೆ. Here also, here theta is the angle between the two vectors, vector ST and vector PQ. Then cos theta is equal to, and I will take another one, cos theta is equal to modulus of vector PQ dot vector ST whole divided by modulus of PQ into modulus of ST. Clear? Magnitude of vector PQ into magnitude of vector ST. Artha aayta makla? This is the case. So cos theta is equal to magnitude of, sorry, cos theta is equal to modulus of PQ dot ST divided by mod of PQ into mod of ST. Then just observe here. So what we have PQ? So PQ is ನೋಡಿ, vector PQ ಏನಿದೆಪ್ಪ ನಮಗೆ D dot n cap ಇದೆ, and vector PQ is equal to D vector B1 cross vector B2 whole divided by modulus of B1 cross modulus of B2. ಅರ್ಥ ಆಯ್ತಲ್ವಾ? And just observe here. So PQ is equal to D into n cap ಇದೆ. So modulus of PQ ಏನಾಗುತ್ತೆ? Mod of PQ is equal to, just observe this, very important, D is the magnitude and n cap is the unit vector. Corresponding magnitude is 1. So therefore we left it here D. And vector ST ಏನಿದೆ ನೋಡಿ. So vector ST ಇದೆಲ್ಲ, this is the vector joining these 2 points with position vector A1 and A2. So corresponding vector ಏನಾಗುತ್ತಪ್ಪ ಅಂದರೆ vector becomes vector A2 minus vector A1. Vector A2 minus vector A1, comma. So modulus of vector ST na, I will take this as here just ST. So ST represent my distance, that is nothing but magnitude. So this is the magnitude of vector ST is equal to ST. Then cos theta becomes, cos theta ಏನಾಗುತ್ತೆ? Cos theta is equal to modulus of, what is the PQ here? D into B1 cross B2 dot A2 minus A1. So last ಬರೀತೀನಿ ನಿಮಗೆ, just write on here. Cos theta is equal to D into B1 cross B2 dot A2 minus A1. Denominator ಏನಿದೆ ನೋಡಿ, B1 cross B2 ಇದೆ, right? B1 cross B2 magnitude. So what about modulus of PQ here? Modulus of PQ is, vector PQ is D into ST. Here by the modulus. And here D and here D get cancelled. So what we have? Cos theta, cos theta ಬರೀತೀವಿ ನೋಡಿ. Cos theta is equal to modulus of B1 cross B2 dot A2 minus A1 whole divided by, this is very important, first ನಾನು ST ಬರೀತೀನಿ, okay? ST remaining terms ಏನು ಉಳಿತು ನೋಡಿ, D get cancelled there, what will left there? Modulus of B1 cross B2 ಬರುತ್ತೆ. This is the magnitude of B1 cross B2. This is a cos theta. Then equation 2 observe ಮಾಡಿ. What is the equation 2 ಏನಿದೆ? PQ is equal to ST into modulus of cos theta ಇದೆ. So cos is nothing but we get this expression. Okay, this call is equation number 3. ಅರ್ಥ ಆಯ್ತಲ್ವಾ? So take a pause and note on all things what I have written here. Okay. So let's substitute equation 3, sorry, equation 3 in equation number 2. So what do happen? We'll explain. Substitute equation 3 in 2. We get, so what will happen there? PQ is equal to ST ಹಾಗೆ ಬರೀರಿ. ರಿಮೈನಿಂಗ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ cos theta ಏನಿದಪ್ಪ ನಮಗೆ B1 cross B2 dot A2 minus A1 whole divided by ST into magnitude of B1 cross B2. This is the expression. Just observe here, ST and ST get cancelled, right? So what do happen? PQ is equal to B1 cross B2 dot A2 minus A1 whole divided by magnitude of B1 cross B2. So here PQ nothing but the shortest distance between the two lines. ಅರ್ಥ ಆಯ್ತಲ್ಲ, ದಟ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ಡಿ. ದೇರ್ಫೋರ್ the distance between given skew lines or given skew lines or skew lines is, take this as here vector form. D is equal to what we have, b1 cross b2 vector b1 cross vector b2 dot a2 minus a1 whole divided by modulus of b1 cross b2, modulus of b1 cross b2. This is the vector form to find the distance between the given two skew lines. Take a pause and note down all the things what I have written here. Now dear students, I would like to derive the equation of line or find expression for line distance between the two skew lines in Cartesian form. Cartesian form derive madandra. Cartesian form the distance between the lines, and the lines here skew lines, and the equation is x minus x1 divided by a1 is equal to y minus y1 by b1 is equal to z minus z1 by c1, and the second equation is y minus y2, sorry, x minus x2 divided by a2 is equal to y minus y2 divided by b2 is equal to z minus z2 divided by c2 is the distance between the two skew lines in Cartesian form. This is the Cartesian equation is D is equal to modulus, just observe this is very important, ಇಲ್ಲಿ ನೋಡಿ. So b1 cross b2 dot a2 minus a1 ಇದೆ, this is nothing but dot product. b1 cross b2 dot a2 minus, so a2 minus a1 represent vector ಆಗುತ್ತೆ. So vector dot corresponding cross product is scalar triple product ಆಗುತ್ತೆ. Scalar triple product ಹೇಳಿದೆ ನಿಮಗೆ. So when we have the three vectors, vector a, vector b, vector c, scalar triple product is vector a dot b1 cross b2. So when you represent in determinant form, we get here determinant of 3 cross 3. So first row represent the scalar component of vector a, second row scalar component of vector b, and third row scalar component of vector c. Here also first ಇಲ್ಲಿ ನೋಡಿ, a dot b is nothing but b dot a because commutative law holds good in dot product. ಇಲ್ಲಿ ಅಂತ ಅಂತೀನಲ್ಲ, a2 minus a1 dot b1 cross b2 ತಗೊಳ್ಳೋಣ, a2 minus a1 dot b1 cross b2, and just observe here a1 b1 c1 a2 b2 c2 are the direction ratios of line L1 and L2 respectively. ಇಲ್ಲಿ a2 minus a1 ಇದೆಲ್ಲ x1 y1 z1, this is the point lies on line L1 or L1 is passing through x1 y1 z1, similarly line L2 is passing through x2 y2 z2. So this expression becomes x2 minus x1 second row y2 minus y1 z2 minus z1. ಅರ್ಥ ಆಯ್ತಲ್ವಾ? ದಿಸ್ ಈಸ್ a2 minus a1. Here a1 is ಬೇಕಾದ್ರೆ ಬರೀತೀನಿ ಲಾಸ್ಟ್ಲಿ. ಸೊ a1 is what we have x1 I cap plus y1 j cap plus z1 k cap and vector b1 cross b2 is it. So this becomes a1 b1 c1 a2 b2 c2 whole divided by, this is important, square root of magnitude ಇದೆ ನೋಡಿ. So magnitude of what? b1 cross b2. Just observe ಇಲ್ಲಿ ಏನು ಮಾಡ್ತೀನಿ ನೋಡಿ, b1 c2 minus b2 c1 whole square plus second one c1 c2 ಈ ಕಡೆ ಬರುತ್ತೀನಿ, c1 a2 minus c2 a1 whole square plus is under the square root. Last one a1 b2 minus a2 b1 whole square. This is a1 b2 minus a2 b1 whole square. Under the square root. So this is the expression to find the shortest distance between the two skew lines in Cartesian form. So in Cartesian form. So neat in Cartesian form. This is the case in Cartesian form. This is vector form. So total derivations idella, this will carry 5 marks. Total weightage is 5 marks question. Take a pause and note on all the things what I have written here. So next we will discuss about important note. Note 1. The shortest distance between the two skew lines. So when they give one vector form, vector r is equal to a1, vector a1 plus lambda into vector b1, and vector r is equal to vector a2 plus mu into b2. So these are the vector equation of the given two lines, and corresponding distance is d is equal to modulus of b1 cross b2 vector b1 cross vector b2 dot vector a2 minus a1 whole divided by b1 cross b2. So artha aitalva. And the second one, note 2. So in the given Cartesian form, the shortest distance between the two skew lines x minus x1 by a1 is equal to y minus y1 by b1 is equal to z minus z1 by c1, and x minus x2 by a2 is equal to y minus y2 by b2 is equal to z minus z2 by c2. Distance d is equal to modulus of, first we have the determinant, x2 minus x1, y2 minus y1, z2 minus z1 in first row, second row a1 b1 c1, and third row a2 b2 c2. Whole divided by square root of, so vector formula nimage magnitude of b1 cross b2 idi ille enide appo nimage square root of b1 c2 minus b2 c1 whole square. Very simple. b1 c2 minus b2 c1 whole square plus ನೋಡಿ c1 c2 ನ ಈ ಕಡೆ ಬರ್ಕೊಳ್ಳೋಣ. Just take cross multiplication. c1 a2 minus c2 a1 whole square plus a1 b2 minus a2 b1 whole square. This is the square root of that. So note 1 and note 2. So these are the method to find the shortest distance between the two skew lines when they given in vector form as well as in Cartesian form. So let us discuss about the one problem on the same thing. Okay. So here, so what they given? Find the distance between the lines L1 and L2 whose the distance vector equations here given by vector r is equal to vector I plus j cap plus lambda into 2i minus j plus k cap, and second equation is 2i plus j minus k cap plus mu times of 3i minus 5j plus 2k cap. Okay, so I'll solve this one. Solution. Given vector r is equal to, first vector enadi, vector r is equal to I cap plus j cap plus lambda times of 2i minus j plus k cap, and the second equation 2i plus j minus k plus mu times of 3i minus 5j plus 2k. These are the given two lines. First comparator. So what are the important parameter we obtained here? So we have to take b1 b2 and a1 a2. Compare given equations with vector r is equal to vector a1 plus lambda into vector b1, and the second equation vector r is equal to a2 plus mu times of vector b2. We get vector a1 is equal to vector a1 ali, just we have I cap plus j cap, vector a2 sorry b1 ಬರ್ಕೊಳ್ಳೋಣ, b1 is equal to 2i minus j plus k cap, and vector a2 is equal to a2 is the second one, this is 2i plus j minus k, and vector b2 is equal to 3i minus 5j plus 2k, 3i minus 5j plus 2k. Okay, this is the vector a1, a2, b1 and b2. Then we have the vector form. So d is equal to modulus of b1 cross b2 dot a2 minus a1 divided by magnitude of b1 cross b2 ಇದೆ. So the distance between the given lines is, for the expression d is equal to magnitude of b1 cross b2 dot a2 minus a1 whole divided by b1 cross vector b2. This is the expression d is equal to. So first find b1 cross b2. Now vector b1 cross vector b2 product padana. Just remember the cross product or vector product of two vectors. Cross product d is equal to ಇದೆ. So here b1 cross b2. What is the first row ಏನಾಗುತ್ತಪ್ಪ? For b1 cross b2 I j k, and the second row is followed by the scalar component of the vector b1. So ಏನಿದೆ ನಮಗೆ 2 minus 1 1 for b2, 3 minus 5 and 2. Expansion I times of minus 2 plus 5 ಆಗುತ್ತೆ. Minus into minus becomes plus 5 ನೋಡಿ. Minus 2 minus of minus 5 ಆಗುತ್ತೆ. Because we have negative sign, so minus into minus becomes plus. Second term is followed by negative sign, minus j cap of corresponding row and corresponding column can be neglected. 2 into 2 is 4 minus 3 into 1 is 3 plus k times of last one, neglect corresponding row and corresponding column. So what do you append here? 2 into minus 5 minus 10 minus of 3 ಬರುತ್ತೆ. So this becomes plus 3. Minus into minus becomes plus. So totally we left with here 3 into I cap minus j ಇದೆ. So here we have 1. So therefore minus j minus 7 k cap. This is vector b1 cross vector b2 is equal to 3i minus j minus 7k. And similarly what we have the expression ನೋಡಿ, modulus of b1 cross b2 ಇದೆ, ಅದನ್ನು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. So therefore mod of b1 cross b2 is equal to square root of magnitude 3 square plus minus 1 whole square plus minus 7 whole square. This becomes 9 plus 3 square is 9 minus 1 whole square is plus 1 plus 49. So total we left it here 59. This is vector b1 cross vector b2. Similarly we need to find a2 minus a1 and a2 minus vector a1. What is the vector a1 ಏನಿದೆ? I cap plus j cap minus a1, sorry this is a1, second ಬರೀಬೇಕು, first write a2. So what is a2 here? 2i plus j minus k cap, 2i plus j cap minus k cap minus I cap plus j cap. Simplification ready? So to go with component to component, 2 minus 1 into I cap, for j 1 minus 1 into j cap plus, here we have minus k, just write minus k, ಹಾಗೆ ಬರೆಯುವ minus k. This is I cap plus 0 into j cap minus k cap. This is vector a2 minus a1. This type of expression, we have another expression, right? In numerator ಏನಿದೆ ನಮಗೆ. So what we have here, b1 cross b2 dot a2 minus a1. Now so and b1 cross b2 dot a2 minus a1 is equal to b1 cross b2 ಏನಿದೆ ನೋಡಿ, write the expression 3i minus j minus 7k cap dot I cap minus k cap. Again go with the dot product, means here component to component ಏನಾಗುತ್ತಪ್ಪ ನಮಗೆ. So this is equal to right here 3 into 1 is 3 plus 0 because j component here of z, so here 0 ಆಗುತ್ತೆ. and the last one minus 7 minus 1 plus 7 ಆಗುತ್ತೆ. so total we left with here 10. therefore b1 cross b2 dot a2 minus a1 is equal to 10. We have obtained all the values, right? So numerator b mod of b1 cross b2 ಬಂದಿದೆ, b1 cross b2 dot a2 minus a1 also we are obtained. So then substituting the, therefore the distance is given by, or distance between the given two skew lines given by d is equal to, substitute a numerator is 10 divided by root 59. This is the value. ಅರ್ಥ ಆಯ್ತು ಮಕ್ಕಳ. here the important is first take the vectors b1 a1 b1 a2 b2, then find the expression b1 cross b2, then find the corresponding magnitude, then find a2 minus a1, find the dot product of this one b1 cross b2 dot a2 minus a1, then substituting this equation we get the distance between the given two skew lines. Take a pause and note on all the things what I have written here. Just observe here. So in this class we had a discussion on finding the expression for or find the distance between the two skew lines. D is equal to in vector form as well as the Cartesian form. ಅರ್ಥ ಆಯ್ತಾ ಮಕ್ಕಳ. So in our next class I am going to discuss about the distance between the two parallel lines in case of 3-dimensional geometry. Thank you all.